Hello students, today we are going to learn about Parallelogram Law of Vectors. We are going to use the parallelogram law in order to do addition of vectors. Here we are going to take two vectors and we are going to add. Let us see how we can proceed with the process. Let me take a vector, fine. Let us take a vector A vector. Okay, this is the A vector. This is the point, starting point O, and this is the A vector. Let us say this is point P vector A. Let us take another vector. Let us assume that the vector is B, right, and it is represented by OQ. This is B vector, fine, and this is certain angle. Let us say these two vectors are subtending an angle of theta. Theta is the angle between these two vectors A and B. So now what we have to do? We have to construct a parallelogram. How do we construct a parallelogram? We take a parallel. This is tail, this is tip. This is tail, again this is tip. Go to this point and take it parallel. Shift the vector parallel to itself and draw a line like this. Okay? But the condition should be the magnitude, the length of the two things should be same. The length has to be same. That is main condition, and the direction also ought to be same. Now let us draw the other one which is parallel to this, right? This is going to be parallel to the A vector, fine, and I am taking the vector parallel to A vector, fine. Okay. Let us say this point is R. Let us now join the point O to R, which gives you the resultant. Okay, so this is the line which I am drawing, which is the diagonal, fine, and that is going to be this. Okay, so let me write the angle. This whole angle is theta, and this is the resultant C vector, which is equal to A vector plus B vector. Now how are we going to calculate the resultant, that is addition of these two vectors? How are we going to get it? It is not normal addition A plus B, because these two vectors are subtending an angle between them theta. So we have to consider that. For that, what is the method actually? First, I extended something more. The A vector, which is the basic vector here, I extended something more, extrapolate it, and I drop a normal at this point. Okay, from resultant I drop a normal. Okay, so I got P, Q, R, S, and this is the normal 90 degree. You know that this line and this line are parallel, and this line and this line are parallel. So the angle theta and this angle here also will be theta. Now it's very simple, right? I got a triangle, right angle triangle RPS. Okay, so this is A vector and this is nothing but same thing. This is B vector and this is again A vector. We know these values are with us. Okay, let us take the triangle RPS. RPS this is a right angle triangle. In this, what is angle theta? What is angle theta? That we are going to define. First we will define sine theta. What is sine theta? Sine theta is perpendicular upon hypotenuse. Perpendicular is RS. So RS upon hypotenuse is PR. PR. Let me write it. Now, what is PR? magnitude is the B vector, okay. So PR is B, so RS upon B. I take only the magnitude. I told you modulus of vector B gives me the magnitude B. Simply I write it as B. Or I can write from this RS is equal to B comes over here, B sine theta. Fine. Now, in the same triangle, what is cos theta? Let us define cos theta. Cos theta is the base upon hypotenuse, right? The base. What is base? PS. PS divided by, what is the hypotenuse? Again PR, which is equal to PS divided by, PR is again B, the magnitude of it. So B, which is equal, so from this we can get PS is equal to, B comes over here, B cos theta. I hope you are clear about these 2 points. One is, one part of it, what is this value and what is this value. I represented these 2 values in terms of sine theta and cos theta, and the known value which I am having here, that is B. This known value, I have used it. I hope you understand this first part of it. Now we can proceed further. Fine. Now you see, I have taken all these things. I am going to erase it now. Okay. And I will only take RS is equal to, I am going to take here RS is equal to B sine theta and PS is equal to B cos theta. Okay. Let me remove all other things, because we are going to go to the next step of deriving the parallelogram law of vectors. Okay. Now watch carefully. This is C. This is C, which is A plus B. Right. Now how will I find this C? I can do one thing. I can take a triangle, a bigger triangle I can take. Okay. Let me assume the triangle is R, okay, watch carefully, R, O, S. In the triangle R, O, S, okay, this is the triangle which I have taken, R, O, S, that's a big triangle. Tell me, in this triangle, what is OR square? OR square is equal to, this is the hypotenuse, right? OR squared is equal to OS square plus the perpendicular RS square. I hope you understand. In this whole triangle, I wanted to find the resultant value. For that, what I do, I take this value square using Pythagoras theorem, that is equal to OS square plus RS square. But what is OS? OS is OP. OP is A vector plus this value PS. Okay. So I will write here OS, that is OP plus PS the whole square plus RS square. I hope you understand this point. Yeah. This OS can be written as OP plus PS. Right. Now what is OP? That is A vector. That is the magnitude of A, the length, that is A plus. What is PS? Just now we calculated, PS is B cos theta. So B cos theta, what? Whole square plus. Now what is RS? RS is B sine theta, the whole square. Keep this in mind. B sine theta, the whole square. That is equal to, look here carefully, A plus B the whole square. What is A plus B the whole square? A plus B the whole square is identity A square plus B square plus 2AB. Let me write it now. That is A square plus B square, that is B square cos square theta. The square holds good for both the terms. Okay, plus 2AB, 2 into A is capital A into B is capital B cos theta plus. I hope you understand. It is simple a plus b the whole square formula, a square plus b square plus 2ab. Now what is this? This is b square sine square theta. Remember, the square holds good for b as well as sine, so b square sine square theta. That is equal to a square, let me take this first term, and 2ab cos theta plus 2ab cos theta plus. Now I have left with only these two terms, that is b square is common, so b square into. Now what you have? Cos square theta plus sine square theta, which I can write it as sine square theta plus cos square theta. Okay, what is sine square theta plus cos square theta? This is nothing but equal to 1. Okay, so we have the total. What is OR? OR is nothing but C. Okay, so I can again write OR square, and I can start from here C square, I can write C square, I can write C square here. So again let me erase this whole part of it, fine, and we don't need all these things now. So we have C square is equal to A square plus 2ab cos theta plus b square. I have got this value. Now I can erase the whole part of it. Yes, now I can remove everything because I got a final result with myself, right? Now what is C? C is equal to under root a square plus 2ab cos theta plus b square. So this is called parallelogram law of vector addition. So whenever you do a problem based on this, this is what you are going to do, where the theta is the angle subtended between the two vectors A and B. I am going to take simple cases, that's very important. We will take case 1. What is case 1? We are going to talk about the angle, right? Now let us say this is vector A and this is vector B. They are subtending an angle of theta. Now suppose this angle theta is 0 degree. That is collinear. If theta is equal to 0 degree, A vector and B vector are pointing in the same direction. That means when theta is equal to 0 degree, cos 0 will become 1. Fine. Now let us substitute in the formula. C is equal to under root a square plus cos theta has become 1, 2ab plus b square. Now what is this actually? This is nothing but a plus b the whole square under root. Okay, that is nothing but a plus b. That is C is equal to a plus b. That means you have to just add. It's very simple. If this vector is representing 4, this is representing 3, so 4 plus 3, you add them, you get the answer. It's a very simple, straightforward one. Case 1. Okay. Now I am going to move to case 2. Fine. Yes. Now what is the case 2? Vector A remains as it is. Vector B is subtending an angle theta, but I change this theta in the opposite direction. That means they are non-collinear. One is 0 degree, 90 degree, 180 degree. It is in the opposite direction. Then what will happen to the formula? Let us see what will happen to the formula. Theta is equal to 180 degree. This is case 2, and cos 180 degree is equal to minus 1. If it is minus 1, cos this has become minus 1. Instead of plus, we will put a minus sign here, and instead of plus, this will become minus, and a minus b the whole square, it will become simply a minus b. So your formula will be a minus b, sometime a difference of b, whichever is big you can subtract from that because it's all magnitude. So I said to you before that if this represents 4 and if this represents 3, right, this is 4 and this represents 3, so the left out will be 4 minus 3, which is equal to 1. That's why you are having this value. Now our last discussion is going to be, if suppose these two vectors A and B 0 degree 180 degree, cos 0 1, cos 180 minus 1, if theta is equal to 90 degree orthogonal vector, if these two represent theta is 90 degree, then what will happen to the resultant? This is going to be the last case, case 3, which is going to be case 3 with theta is equal to 90 degree. And what is cos 90? Cos 90 is 0. Cos 90 is 0. Okay. So now it's very simple. Let me just remove all these factors here because we have done the two cases, collinear and non-collinear, right? So this term totally gets off. Fine. So you get C is equal to under root A square plus B square. What is this? This is nothing but Pythagoras theorem. What has happened actually in a simplest form, right? So what has happened is one vector is like this, right? One vector is like this, right? And another vector is like this, fine, perpendicular. And what has happened? We have now calculated. You can shift this vector perpendicular to this like this, fine. It should be keeping the same length, right? And this gives me the resultant, right? And this is nothing but a right angled triangle. So C is equal to A and B values when we take it. We use Pythagoras theorem. So C is equal to A square plus B square. All this time we are talking about only magnitude, A vector, modulus of it, A, B vector, modulus of it, B, C vector, modulus of it. We have to take the C vector modulus of it, that is C. So this is how we are going to derive all this. We have derived all these things. I hope you understand this. Very important, very simple, just mere substitution. It just requires basic trigonometric functions and the triangle, right angle triangle we have taken. In the next video, we also can study about if the angle with the resultant is something like alpha or beta, then what will be this angle? That also we can calculate, which we will do in the next video. Thank you so much.